Hello, viewers and learners from whichever point or place you are. Now, today we want to look at quadratic equations or expressions and basically focusing on perfect squares. Now, what are perfect squares? Now, during factorization, we talked about uh, quadratic expressions or equations that can factorize themselves into two equal parts. Those will be known as perfect squares. So we are going to look at perfect squares in this lesson. Now, a quadratic expression that can be factored into two equal parts is the one that we are calling a quadratic equation or a quadratic expression. So when you're given an expression like ax squared plus bx plus c, whereby a and b are coefficients of x squared and x respectively, then c is a constant, it means that the above equation or quadratic equation is a perfect square if and only if the coefficient of x divided by 2 then squared, it will give you a multiplied by c. If we take the coefficient of x, which is b, you divide with the 2, then the answer, the quotient you square, it should give you the coefficient of x squared, which is a, multiplied by the constant, which is c. So basically, if that condition is met, then it means that is a perfect square. Now, we are going to look at a question. A question says, add the missing terms to make the following expressions perfect. The first expression is x squared plus 8x plus dash. Now, you can see there is x squared, you can see there is 8x. So what is missing is c, that is the constant. But we know from this equation that the value of a is 1, before x squared there is 1, the value of b is 8, and the value of c is what we are looking for, that is the constant. We know that if we take the value of b, you divide it with 2, then you square, you will get the value of a multiplied by c. So in this equation, the value of b divided by 2, it becomes 8 over 2. Then if you square, you should get value of a, which is 1, times a value of c, which is c. That is the one we are looking for. So this one breaks down to 1 multiplied by c should give us, that is 8 over 2 is 4, then 4 squared is 16. So it means c equals to 4 squared, and therefore c equals to 16. So basically the term to be added is c, and remember c is a constant, so the term to be added is 16. And that's how you carry out that's how you show that a certain quadratic expression is a perfect square. We can look at the next question, and it says, what must be added here for it to be a perfect square? So you have 49x squared minus dash plus 4. Now, there is x squared, its coefficient is there, and there is a constant which is 4. So what is missing is the coefficient of x and the x itself. Now, we have the value of a, which is 49. The value of b is what you are looking for. Then you have the value of c, which is 4. Now, we know that if we take the coefficient of x, which is b over 2, then you square it, you must get a multiplied by c for it to be a perfect square. So it means that b over 2 then squared, it should give us, that is 49 times 4. Now 49 times 4, this one means b over 2 squared, this one should give us 196. Now at this particular place we find the square both sides. So find the square root both sides. If you find the square root both sides, then on the left hand side you'll have b over 2, and on the right hand side you'll have the square root of 196 as either plus or minus 14. So take when the square root on the right hand side is positive 14, so you'll have b equals to 28, or the value of b equals to negative 28. Therefore, the term to be added is either 28x, or the term to be added is either negative 28x for the above expression to be a perfect square. We can also look at a third example again and see. Now, in a third example, you are presented with dash minus 18x plus 81. You are told what must be added here for it to be a perfect square. Still, we go back to our condition that says that if we take the coefficient of x, that is b, you divide it with 2, then you square the quotient, you must get a multiplied by c for it to be a perfect square. So from our equation here, you can see that the value of a we don't know, but we know it is x squared. So we need to find what is this coefficient before x squared. The value of b is negative 18. The value of c is 81. So we know that b over 2, then you square, should give us a multiplied by c. So equate the values inside here, and you find that negative 18 over 2 you square, you should get a multiplied by 81. A is the unknown that you are looking for. So it means that negative 18 over 2 is negative 9. Then you square it, you'll get that is 81a. That is a multiplied by 81. So it goes ahead to say that negative 9 squared will give us 81, which is 81. Divide both sides by 81, and you find that a equals to 1. So therefore, the term to be added to this expression to make it a perfect square is 1x squared. And 1x squared is just x squared. So that's how you determine that a certain expression is perfect or not. In that, for any perfect expression, the value of b, that is the value or the coefficient of x divided with 2, then you square it, it should give you the coefficient of x squared, which is a, multiplied by the constant, which is c. So you have a small exercise that you can try it out to see. They have been given two equations, 121x squared plus 22x plus dash. What must be added to this expression to make it a perfect square? Then another one, 16x squared plus dash plus 36. What must be added here to make it a perfect square? Thank you for watching and learning. You can like and subscribe to my YouTube channel, BC Online Math, my Facebook channel on BC Online Math. Thank you.